So JavaScript promises. That's what I'm talking about tonight. And it's I think, pretty essential to me every day. I work with promises. So I'm actually curious about the audience here, who works with promises every day and who it's new to. It was tough coming into this, trying to figure out what I need to present, because there's some fundamentals to learn, and there's definitely some more advanced stuff that we could talk about, but I want to leave behind anybody who's new, so definitely leaning towards the basics here in this presentation, and if you already know it really well, then maybe you'll relearn something new. It was going to be a deep dive. Now it's just a dive. Hopefully not a nose dive. So I'm Mark Duckworth. I work at a company called Ionic Security. I'm a JavaScript engineer. So yeah, anybody who in the audience doesn't really work with promises on a daily basis, or they're new? Okay, awesome, great. Okay, so last time I came here, people were giving away swag, and I'm just doing this on my own, and I didn't have any company swag. But if you ask questions or whatnot, I have a bunch of Nutella snacks. Everybody loves Nutella, so go for it. You know, if I start mumbling, just let me know, and Nutella, or ask a question. All right, so a couple of things that I know about promises, the way that I view promises, right? So first of all, promises are a proxy to the result of an operation, right? So they're not the result of an operation. A promise may be returned by a function, and it allows you to get the result, the internal operation inside of that function, whatever that is. If it's something asynchronous, or it could be synchronous, whatever, it's an object that allows you to get the result. So promises also allow you to get the result of a past or future operation. So, if you have an asynchronous operation and it's not going to complete for a long time, you can call into the promise and say, give me the result of this operation when it's complete. Or you can call into a promise first. If you have a promise for an operation that completed, I don't know, a long time ago, say when you initialize your application, you loaded up a config file and stuck that config in a promise, and then later during the execution of your application, you want to get that config again, you can call into that promise and create the result. Right? And then final thing, so promises are often used to represent the eventual result of an asynchronous operation. So most of the time when you look up promises, this is kind of the definition you get to represent the eventual result of an asynchronous operation. And that's definitely true a lot of the times, so I threw it in here. They're very often used for asynchronous operations, so I/O and computations that may happen on the background thread. But that's not the only thing that we use for. So I'm going to switch over to some coding examples to sort of review those things we talked about, right? So I said it was going to start very simple. The simplest operation, right? 2 plus 2, right? And we assign that result of that operation to our variable result, right? And then on the next line, we just log that value out. So if we wanted to change this such that we resolve the promise to hold the result of that operation, we can do it like this. So now this line here, we said promise.resolve, that's created a new promise, and we resolved it with the result of our operation, 2 plus 2, right? And so what if we did console log again? What if we run this? Oh, save. Oh yeah. Sorry, I'm used to web time and it saves automatically. Sorry. Thank you. Said who wants to tell me? Anyone? All right. So what do we have? So we executed our first statement on line 4. We got the result. We logged that out. We see that the value is 4. And then we created a promise, and we resolved that with the result of the operation. We assign that to P. And then we log P. Well, so we see that P is just an object. So a promise is just an object. Right? So how do we get the result out of that promise? Right? We use the then method. Right? And then, so we do P.then. We give that a function. And first parameter is a function that's called onFulfilled. Well, you don't have to give it a name there, just an anonymous function. And then it takes an argument value. So when this promise resolves, our onFulfilled handler will be executed, and we'll get the value of the operation. So cool. So we see, you guys can see that at the bottom, but so now with that line, line 10, or 9 and 10, we can get the value of the promise is fulfilled out of that promise. So that's a really simple case. Any questions so far? Yeah, so all these examples are using Node. So we're just using ES6, right? Promises built in. And yeah, I should have started with that. They're built into ES6, and they're going to be available in most browsers, except for IE, of course. And then, so yeah, there are other promise libraries that you could use now as a polyfill, but as far as going forward, I would just recommend sticking with what's going to be in the language, and then maybe supplementing that with a library if you need to. Cool. So let's look at a function that returns a promise. Right? We have this function, right? It's a simulation to compute the meaning of life, and it returns on line 10. It returns a promise. Right? So we use the promise constructor. We say return new promise. And we give that constructor a function, right, executor, right, and that takes 2 parameters, resolve and reject. Right. So here's the actual logic of our function, right? It's just going to do a timeout, set timeout. It's going to wait some amount of time, something reasonable for demo, and then it will call resolve, right, which was asking here as a parameter. And we'll resolve this promise with some result. So this is just a basic function, but that could have been something more meaningful, like an I/O operation that resulted in the asynchronous completion. Yeah. So the point is, when we call compute meaning of life, the actual operation is not going to complete until 600 milliseconds in the future. So if we do right, this, that's going to return a promise. And then we can do P.then. So once again, even though this operation, keeping of life, doesn't complete synchronously, it completes 600 milliseconds in the future, our code 13 and 14 are going to go ahead and execute, and we can just sign up basically to be for our unfulfilled handler to be called when that operation completes. We can run this. Meaning of life is something. So likewise, we can sign up to get the result of operations from the past. Right? So I mentioned that example of application initialization. We might have a function that loads our config file, and that's going to complete asynchronously, right? It's going to return a promise, and then when that promise is fulfilled, we just log out to say the config was loaded. But we want to do something else with that configuration file. We're just going to actually log out the contents of the config file. So here we have one place where we call config promise.then and pass it fulfilled handler. And then once again, for the same process, promise, we call then. So what we see there is we can actually call then many times for the same promise. And all of these unfulfilled functions will be called when the promise is fulfilled. And they'll be called in order. So first this one will execute here because it was added first, and then this will be executed. Cool. And so we could also, so it would actually make more sense if we're saying we want to, we can use this promise anytime, right? So we showed earlier that we could use a promise, or use a promise to get access to a result of an operation that completes in the future, but we can use the promise to access a result of an operation that completed in the past. So we'll just use a set timeout to say delay using the promise for a second. So I don't know if you guys saw that, but when we ran it, get that initial config loaded, and then a second later, our actual use of the promise here on line 12, this code executes, and we can still use the promise. So all pretty basic stuff. Any questions yet? All right. So what if our operation fails, right? We've talked about operations that are successful, and we use the promise to get as a proxy to the result of the operation. But if the operation fails, how does it work? So let's say we have a function that returns a promise async divide. Does that make sense? But so we give this, pass this function a dividend, divisor, and it will do the division 250 and 250 milliseconds. So it'll just reset timeout. And it will resolve that promise in the future. Right? So that's our async divide. When we call async divide, right, it returns a promise. We call then, pass in the unfulfilled handler, and then we log out the result. So let's execute the code. We're going to divide 100 by 10. And the result is 10. So what if we do something stupid like divide by 0? So what's our function going to do here? Basically divide. Well, I actually didn't realize that JavaScript handles that gracefully if we do a divide by 0. So today, or the other day. Yeah, well, it'll actually return infinity. That's what I thought. Yeah. So, yeah. I don't know. Weird. Anyway. Then it's not. Anyway, so I had to put this in here. Little input argument checking. So we say if divisor is 0, then we'll reject our promise, right? With a new error. So that's what we did here. We can divide 100 by 0. What happens? Okay, so nothing. We didn't get anything printed out, right? Well, that's because this function that we passed in to them is only called the promise is fulfilled, so resolved successfully. If the promise is rejected, which would indicate an error, we have to pass a second argument. And that takes, well, the name of this parameter is reason. So, saying a promise is rejected with reason. So, if this promise returned by async divide is rejected, this function will be called, and we'll say console log. Right, and so we'll just log our error here. And so that's what we saw, because our promise was rejected, this was called. Out here. Yeah, so, no. So it will actually reject the promise here and then continue on through. So I should have actually had an else statement here. So that's actually something in the future, but I'll go and talk about it. So once you're in a final state, the promise is in one of these states, fulfilled or resolved, or it's resolving, it can't change. Right? So even if you did try to resolve or reject with some other value, it just wouldn't do anything. Right. Cool. Okay, and then so I wanted to show you some sort of shorthand ways we could clean this up. So then we passed in two functions. So we actually could have also written this as catch. So async by then, if it's fulfilled, this will get executed. If not, essentially the rejected value will fall through and we'll hit this catch, right? And we'll call on rejected. So that's a nice way to sort of clean up your code. It makes it pretty readable, I think, compared to having two functions as arguments to the end. Although there are some, you do have to sort of understand how you chain promises. And so another thing to mention, that catch is just shorthand for then and passing in null as the first. So we're basically calling then and passing in null for our own fulfilled handler. So if the promise was fulfilled, nothing would happen. If the promise was rejected, only this function would get executed. Again, that's catches. Let's see. All right, so back to the slides. So promise resolution in states. So talking about states, so all promises start in the initial state of pending, and then they either transition to a final state of fulfilled or rejected. When a promise is in a final state, it's just considered to be settled, right? So you'll hear that term sometimes. When a promise is settled, it's never going to transition into another state or have another value. And as we've seen multiple times, it will be, or it can be settled with a value, so fulfilled with a value or rejected with a reason. So any questions so far? Yeah, go ahead. Mhm. So when you call then, it won't execute the underlying asynchronous operation again. The promise is just basically represents the result of that operation. So it's a way you get access to the result. It's not by calling then, you're not going to cause that operation to happen again. So to do that, you'd actually have to, say you had a function that was HTTP GET, right? And it returned a promise. And you called HTTP GET with some URL, and there was a network error, right? So the promise you got back would be rejected, and it would always be rejected, right? Even if you got on the network. And then you call then again, that promise you had still represents the result of that initial operation. And so you could just call HTTP GET again once you're back on the network, and then you should get a promise back that's fulfilled with the result. I don't know if that answered your question. Yeah. So I would say that's just in your application's business logic in terms of how it would handle an error condition like that. So, right. Right. Yeah. Yeah, I mean, it's no different than if your logic, your get was synchronous, right? So you said get, and it returned immediately, and it said it failed. Then, yeah, I mean, what do? You just, that's up to you as a programmer to say, you know, I want to handle this, I want to, you know, retry, or I just want to give them an error message to the end user that says, you know, we can't access the network right now. In this case, it's just, you don't really know if it failed until sometime in the future, and you use a promise to figure out that it did, to get access to that result. Go ahead. Mm-hmm. Yeah, also, I think that question kind of goes back to the sort of the JavaScript event loop. I don't want to get too much into it, but essentially, yeah. So whenever the asynchronous operation completes, let's say it's I/O, right? And you get a response back from the server, then you get a message on the message queue or part of that event queue, right? And it's just going to wait there. That's the underlying JavaScript engine. It's not going to process that message, the result of that I/O operation, until all the other code is complete, because there's only one thread. So once your other executing code is complete, then the engine will pick up that message, the response from the server, and then execute the fulfilled handler, hopefully. Right, right. Yeah, you're only going to have, you're not going to have, well, with some exceptions, but I mean, just in general, you have one execution context, one thread of code executing it, so. Yeah, you could, yeah, right. Yeah, I mean, that's a can of worms. We can talk.
You can have as many I/O operations as one code. You can't do computation multiple computation.
Right, right.
You can use like if you need to do multiple computations at the same time, you can have whatever CPU. But for I/O operations, this
Yeah, and the thing with JavaScript libraries, what makes the asynchronous I/O is sort of the underlying implementation is actually executing some code on a separate thread, but it's not a thread that's processing your JavaScript code, right? So there's a thread running that's, you know, talking to the network, and it's, you know, buffering the response and sticking it in memory, but it's not executing JavaScript. So really, there are multiple threads in the engine. I don't know. That's a talk for a different day, I think. But we can talk more about it after this. So promise resolution. So I talked about fulfilled and rejected and resolve, right? And so there's kind of like this underlying magic of moving from the pending state into fulfilled or rejected, right? And that's in this function called resolve. So you execute this promise resolution procedure whenever you call promise.resolve, right? Or you do new promise and you call the resolve method here. Or you do promise.then and you return some value. So then actually returns a new promise and would resolve with this value x. So I'll get more into that. But these are the cases where you'll run this resolution procedure. Right? So it's the procedure's taking you from pending state into some final state fulfilled or rejected. And it's pretty simple, actually. You definitely don't have to know this, but I think it's really helpful when you start returning promises, or resolving promises with other promises. It's kind of cool to know. So you start with a promise, and you want to resolve that with some value x, and the procedure goes like this. If x is some value, any value that's not a promise or a venable, right, then we're just going to resolve that promise p with whatever value you passed in. So it's pretty direct, right? But if you pass, or you try to resolve your promise p with some value x that's actually another promise, then what this resolution procedure is going to try to do, it's going to wait until that other promise is settled, down here, and it's going to wait. Right? It's going to say, well, x will eventually be resolved or rejected or fulfilled, right? And when it is, then we're going to resolve our outer promise p with the value of inner promise x, right? And so this may be hard to wrap your head around just from this diagram. I think it is to me, but being aware of that, it's kind of cool. It's useful when you start chaining promises. So there is kind of a gotcha here, right? We said that earlier, we brought up the question of when I say resolve with some value food, right? And then I try to resolve again or reject. Just right after that, it won't change. But the promise can get resolved and stuck in this kind of pseudo state where it's not really pending and it's not really fulfilled or rejected. It's resolving. And so that's essentially the same thing as being in one of the final states. It won't, once you start the resolution procedure, you can't resolve with some other value. So anyway, let's do some more code. Does anybody know what time I studied? So we can resolve with, so we have a promise, new promise. We're going to resolve that with a string. So we see that we resolved it with a string, and it went through that promise resolution procedure, and the promise was fulfilled, right, with the value that we passed in. So we could resolve a promise with really any valid JavaScript value. And we could resolve it with an object. We could resolve it with nothing at all, right? So this is useful when you may have an asynchronous operation that doesn't actually return anything. You just want to know when it's complete, right? Like maybe sending an email, right? You want to send some emails from your code, and you want to know when they're done, but there's really nothing that's going to be returned from that function that sends an email, right? So ultimately the promise, when you resolve with nothing or undefined, it's just the promise is resolved with undefined. And then finally, you can resolve with another promise. Right, so now we have this outer promise, my promise, and we're resolving that with another promise, right, that gets fulfilled with a value high. Right? And so our outer promise, my promise, ultimately takes on the value of this inner promise. Right? And we'll see that when we run this code. So our outer promise, my promise, is fulfilled with yeah. All right, promises A+. So this is a standard behind promises in JavaScript. It sort of just defines the behavior for at least the then method, and it makes all implementations of promises compatible, which is pretty sweet. So how does it define then? As we've seen this several times now, right? Then takes in two arguments. They're both optional. First is on fulfilled. It's called when the promise is fulfilled, and second is on rejected. Again, optional. It's called when the promise is rejected. And finally, what we haven't really talked about is then returns a new promise. Right? And the promise that returns is the result of onFulfilled or onRejected, whichever one of those was executed. So this does cool stuff, like enables chaining of promises. So we'll go back to our function, compute meaning of life, right? So that returns a promise, promise A, right? And then when we call promise A dot then to get the value, then returns another promise, right? Promise B. So promise A and promise B are two different promises, right? Promise B gets resolved with the return value of this function we pass to them. So it'll get resolved with detail chairs. And once again, 5 minutes? Okay, thanks. Once again, we call promise B dot then we get return another promise. C. I don't have time, but so actually this is kind of messy, right? You can clean up promise chain, make it really nice. Thanks. So now we have a pretty clean chain here, right? This line 4, we create a promise. Line 5, we call then on that promise, and we get a new promise, and then we call then on that next promise. I'm not going to execute that because we'll run out of time. And so you can continue your chains forever, right? You can just then catch. Actually, I think I missed something important. Okay, so one thing, everybody has a promise implementation. There's like thousands out there. As we talked about earlier, it's coming to the JavaScript standard in ES6, right, which is available pretty much everywhere now except for IE. Right? So just my recommendation is stick with what's in JavaScript, but you may want to use some other implementations. They're compatible, so if you end up using an API that returns like a jQuery promise, or an Angular promise, or a Bluebird promise, right, you can resolve them or call them. They just sort of interact really well as part of Promises A+. You don't really have to worry about it. The main difference is how they're created. Sometimes some libraries create promises a different way, so like the Q library and jQuery use this deferred object, which you may have seen if you've used jQuery, right? jQuery.deferred, and then you call deferred.resolve to set the value of that asynchronous function, and then to get the actual promise out of there, you do deferred.promise. So it's just a different way of creating a promise. Let's see. There's a bunch of libraries, support helper methods out there for promises. You'll see some in JavaScript, so promise.all allows you to basically wait on any number of promises to complete. Right? So this statement here is going to wait for promise A, B, and C all to fulfill before the promise all done actually itself fulfills. Right? There's another one, promise.race, which will just give you a promise that is fulfilled whenever the first of A, B, C is fulfilled, and there's a whole bunch more in libraries like Bluebird, etc. So, let's see. They'll just continue to run, I believe. So you just won't. I actually don't know. I've never had a use case for that. Yeah, that's in JavaScript. Or like the core libraries. Let's see. So, okay, just a couple of, I can leave it on these. Wrap things up here. So, couple of things that I like to recommend to people when they're using promises. If you're creating a function that returns a promise, it's good practice to put all of your logic inside of your executor function. So we'll look at a case where maybe I did some argument checking outside of the statement returning promise, and so I did like if type of options foo is not a string, then I'll return a promise that's rejected. Right? No. So let's see. Sorry. Let's see. So we called my func with a valid argument, right? But what if we called it with something that's not an object? Right? We call it with undefined. Right? So then in here, our code, line 5 is actually going to fail, right? Because options is undefined. So we'll try to execute that. Okay, so what happened there is we called into this function that typically returns a promise, and we would expect an error case in that function to return a promise that was rejected. But since we, I don't know, it was an oversight, right? Our function actually threw, right? And so now if I'm consuming this and I now have to wrap this in a try-catch to handle that, I don't want to do that. That's nasty, right? So if I just put all of my logic inside of here, then I would just get this case for free. So what happened now is line 8 through, right? And then in the promise constructor, that was caught, and then the promise that was returned or created there was just immediately rejected. So that's kind of a nice, just wrap the entire function in the promise there and do some nice things. Another thing that I recommend is try to avoid nesting your promises, because it can be a mess. I think people come from callbacks and they say, you're just used to nesting, right? But there's a much simpler way to implement the same function without any nesting. Actually, I think I'm out of time, so you guys can just come take me off the stage, I guess. So we're going to just change this function over to So I'm not keeping track of who's making all these recommendations. There's plenty of detail. Anyway, yep. So we just rewrote that same function using sort of chaining here, right? And we avoid any nested promises. And then it just makes the code much easier to use. Let's see. So yeah. Promises in ES6, right? There's just a screen cap of can I use, right? You see, unless you're writing for IE, then you pretty much get it for free. If you need a polyfill, I would probably look at Bluebird. It looks like it's the API. It does have the promise constructor, just like it's built into the core JavaScript. So you probably transition pretty well if you were using Bluebird, and it has a whole bunch of other helper functions. And with Node, you get it pretty early. I mean, I'm not sure which version of Node has promises, but at least 4. I don't know. I think we're done. We're done. Yeah. Cool. All right.
Thank you.